Good morning, students. Today we are going to see eigenvalue and eigenvector. How to calculate the eigenvalue and eigenvector of the matrix. Okay, this is under module 1. Uh, Before that, how to calculate eigenvalue and eigenvector, you must clear how to form the characteristic equation. What is characteristic equation? What is the formula for that? That is lambda cube minus s1 lambda square plus s2 lambda minus s3 equal to 0. Okay, see the problem. Find the eigenvalue and eigenvector of the matrix A equal to minus 2, 2 minus 3, 2, 1 minus 6 and minus 1 minus 2, 0. Before starting the problem, you have to check A and A transpose is equal. You have to find out the A transpose. Row into becomes column. Minus 2, 2, 3 minus 3 and 2, 1 minus 6 and then minus 1 minus 2, 0. Both are equal? No. A is not equal to A transpose. Therefore, non-symmetric. The given matrix is non-symmetric matrix. Okay. Next, characteristic equation. Characteristic equation is lambda cube minus s1 lambda square plus s2 lambda minus s3 equal to 0. So we are going to find all the values. S1. What is S1? S1 is sum of the diagonals. S1 is sum of the diagonal. Diagonal is minus 1 plus 1. Sorry, minus 2 plus 1 plus 0. You are getting the answer is minus 1. Next, S2 is minor of main diagonal. First, you have to delete the first row and first column and then remaining one. Next, plus symbol you have to use. Next, third one is L. Leaving the last row and last column. This is the third one. This is the plus symbol and this is the first row, first row, first row, first column. This is last row and last column. That is minor of main diagonals. Leaving the diagonal row as well as column. So you have to cross multiplying this 0 minus 12, 0 minus 3, minus 2, minus 1. They are getting the answer is minus 21. Next S3. S3 is as usual determinant of A. How we calculate the determinant of A? Using your calculator. Go to the matrix mode. Use your calculator and go to matrix mode and go to the matrix mode and feed all the values. You can easily get the determinant of A. Next, substitute all the values in the characteristic equation. So, you are getting the characteristic equation is lambda cube plus lambda square minus 21 lambda minus 45 equal to 0. Next, to find the eigenvalue and eigenvector. First, lambda 1 is 5. How you are getting these values? You may have one doubt. Using your calculator. Use calculator. Go to the equation mode. Go to equation mode and press degree. Degree is 3. You have to substitute all the value. A is 1, B is 1, C is minus 21 and D is minus 45. You have to feed all the values. You can easily get the answer is in your calculator shows x1, x2 and then x3. Because x3 value is repeated, so calculator shows only up to x2. It goes to the quotient. So the last value is repeated one. That is minus 3 is repeated. Okay, next we are going to see how we can calculate the eigen vector of the matrix. What is the formula for eigenvector? The formula for eigenvector is A modulus of A minus lambda into x equal to 0. The diagonal elements need not bother about this equation. You are just keep in mind you have to minus lambda in the diagonal elements and all the other elements of are same. Diagonal elements only you have to put minus lambda. Next x1, x2, x3. This is the base of this equation, that is capital I. Next we are going to perform case 1, case 2 and then case 3. Okay, in the first case, what is the first case? What is the lambda value? Lambda value having 5. So I am going to substitute 5. First I am going to substitute the value of 5. What you are getting? First, the matrix becomes if you are substituting the lambda value is 5, lambda equal to 5 in equation I. So what you are getting the matrix is minus 7. Then minus 2 minus 5. So minus 7, 2 minus 3, 2 minus 4 minus 6, minus 1 minus 2 minus 5. Next x1, x2, x3 which is equal to 0, 0, 0. Next we are going to form the equation, row into column. What you are get, how you can form the equation? Just row into column. Minus 7x1 plus 2x2 minus 3x3 equal to 0. Second row. Similarly, second row, 2x1 sorry, minus 4 minus 4x2 minus 6x3 equal to 0. Third equation, minus x1 minus 2x2 minus 5x3 equal to 0. Take it, this is 1 and this is 2 and this is 3. Now, you see the equation. Equations are different or same. See the equation. The three equations are different. So, we are going to use cross multiplication rule. The equations are different. We use cross multiplication rule. What is the cross multiplication rule? How to write x1, x2 and x3. Start with middle value. You can take the equation 1 and 2. What is the coefficient of first equation? You can start with the middle value, that is 2. 2 and minus 3 minus 7 plus 2. The second equation coefficient of middle value is minus 4, that is x2 coefficient, x3 coefficient, x1 coefficient and x2 coefficient. Just you are cross multiplying this. X1 divided by 2 into minus 6 is minus 12 minus 12. Next x2 divided by minus 6 minus 42 and then x3 divided by 28 minus 42. So x1 answer is minus 24 and x2 getting the value is minus 48 and x3 value is 24. So you can divide this eigenvector by 24. You can easily write capital X. Always you can write the eigenvector in column wise. So minus 1, minus 2 and then 1. This is the eigenvector of lambda equal to 5. Next we are going to see case 2. Case 2 is we are going to substitute the lambda value is minus 3. Minus 3. Okay, the matrix we are getting the matrix is 1, 2, minus 3, 2, 4, minus 6 and minus 1, minus 2, 3. Here you are substituting the lambda value in the I equation. Okay, next x1, x2, x3 which is equal to 0, 0, 0. Okay, next see the now we are going to form the equation the same method. X1 plus 2x2 minus 3x3 equal to 0. Second equation 2x1 plus 4x2 minus 6x3 equal to 0. Fourth equation minus x1 minus 2x2 plus 3x3 equal to 0. Now see the equation. If the equations are different, we use cross multiplication rule. But here the equations are same. The equations are same. So you can take any one of the equation. Okay, 1, 2 and then 3. Taking first equation, put x1 equal to 0 and find the other two values. So x1 equal to 0, we are getting 2x2 minus 3x3 equal to 0. 2x2 equal to 3x3, then x2 divided by 3 and cross multiplying the coefficients, x2 divided by 2. Therefore, capital X2 equal to, what is x1? 0. We are putting x1 is 0, x2 3 and x3 is 2. This is the second eigenvector, and third eigenvector is, we are going to find the third eigenvector. See here, the second and third eigenvector is same. The second and third eigenvector value is same, minus 3 and minus 3. You have to substitute the minus 3, the same matrix also here. So, same here also. So, you have to put x2 equal to 0. You have to put x2 equal to 0. Therefore, x1 minus 3x3 equal to 0. x1 equal to 3x3. x1 divided by 3 and the x3 divided by 1. Therefore, capital X3, that is third eigenvector is x2. What is x1? x1 is 3, x2 0 and x3 1. This is the third eigenvector. So, finally, you are writing the conclusion. Finally, you are writing the conclusion, that is, solution is, if lambda equal to 5, if lambda equal to minus 3 and if lambda equal to minus 3. The eigenvector is capital X1 equal to, what is 5? 1 minus 1 minus 2 1. And then for lambda equal to minus 3, capital X2 equal to 0, 3 and then 2. Next, the eigenvector is capital X3 equal to 3, 0, 1. 3, 0, 1. This is the answer. Okay, all of you understand? Thank you.